Okay, 6b. We have find the force on the region bounded by x equals 2y minus y squared, and the y-axis if the upper point of the area is at the surface of the water. Okay, so first we have to make a sketch of the situation here. If you just choose some y values, like 0 for instance, choose a y value of 2 here, because this is what we would plug into x equals 2y minus y squared. You'll notice that we'll get our x values for this. So when y is 0, then x is 0 here. When y is 2, we actually get x is also 0 here. So this is the boundary we're talking about. This little shape here, this area, I guess I should say. And this, the y-axis, is the other boundary region. So really we're just looking at this little area in here, and we actually have to do our L and our dH as before, and this is our fluid pressure integral, right? This time, as always, getting the L's as a function of y and the depth h as a function of y, and integrating with respect to y. So L, if we look at L, it's actually just equal to 2y minus y squared. It's just the x distance, right, from the y-axis. That's all it is. So well, we get that. Then h of y, or depth, as before, we take our 2 meters here and we actually subtract how high our element dh here is. So our element is y, so it's y units high. Therefore, the depth is 2 minus y. Right, so we're getting the depth from the surface here at y equals 2 downward, and that'll be 2 minus y. And W is 9.8 kilonewtons per meters cubed as before. So we're integrating from 0 to 2 here because we're integrating in y, so from the bottom up, because y's go in that direction, we're integrating from 0 y. And in the same time, we'll be integrating from 0 in the y up, we'll be integrating from a depth at the surface here down to 2 meters deep. So that's how that works. So we put 9.8, and then we get our L of y is 2y minus y squared. Our h of y is 2 minus y dy here. We do FOIL on this. Just multiply this out. You get 4y minus 2y squared minus 2y squared plus y to the power of 3. And then we integrate. So notice the integration. First of all, I combine these like terms to give minus 4y squared, and then I integrate it. So integrating this 4y, we get 4y squared over 2. This is 4y to the power of 3 over 3, and this is y to the power of 4 over 4 from 0 to 2. Again, we don't need to do the zeros because the zeros contribute nothing here. When we plug them in, we get zeros when we plug in y value of 0. So doing this, we get 2 goes in here, we do the math here, do all the calculations, and we get 9.8 times 4 over 3, which is 13.1 kilonewtons.